Three particles each of mass m are situated at the vertices of an equilateral triangle of side length a. The only forces acting on the particles are their mutual gravitational forces. It is desired that each particle moves in a circular path while maintaining the original mutual separation a. Find the initial velocity that should be given to each particle and also the time period of circular motion. So we are considering something like this. The first thing that we need to do is to draw a diagram for this entire setup. So I am considering a circle like this, and the three particles are on the vertices of an equilateral triangle uh, drawn on it. So we have a equilateral triangle drawn here. So each particle is having a mass m and are on the vertices of an equilateral triangle of side length a. Now using the side length, the first thing that we need to clear out is to find the radius of the circle. So I can directly write it out that the radius is going to be a by root 3. I hope you know this basic thing. So radius can be written in terms of the side length of equilateral triangle. That radius is going to be a by root 3. Now we are asked to calculate the velocity of each. So now if we consider this problem in a clear way, so we are considering it in this way. So if I select this mass, so there is a gravitational interaction between these two masses which will contribute to force F1, and the another gravitational interaction between these two forces will count for force F2, and the resultant of these two forces is directed towards the center of the circle, which is written as Fr, and it is balanced by the force mv square by r in the outward direction. So this is what is going to be the working process which we will be opting. So the first thing which we are calculating is the value of the resultant gravitational attraction of the two masses. So if I write the resultant magnitude of gravitational attraction for the two masses, so since F1 and F2 are same, so I am calling it as F. So we write it as F square plus F square plus 2F square cos 60 degree square root. So from here we obtain it as root 3F, that is we can write it as root 3 times of G m square by a square. So this is the equation of the resultant force which we have obtained due to the gravitational interaction. Now this gravitational interactions resultant is balanced by the centripetal force Fc. So I can write it as that root 3 g m square by a square is going to be equal to m v square by r, and r can be written as a by root 3. So we are writing it as a by root 3, and from here we can solve it out for v. So we obtain v as the root 3 will get cancelled out, and m will get cancelled out, and we get v as root over g m upon a. So this is the question which is asking find the initial velocity that should be given to each particle. So this is the value of velocity that should be given to each particle so that they can move maintaining the mutual separation. Now the next one is asked the time period of the circular motion. So for we need to remember this value of velocity and the radius as well. So if we calculate the time period, so time period can be written as 2 pi r by v. So r can be written as a by root 3. So 2 pi a by root 3, and the value of velocity was root over g m upon a. So on solving we obtain it as 2 pi root over a cube by 3 gm. So this is the expression for time period.